Till now we have seen how containers control resources like CPU and memory, all handled by C groups. But here's the next problem, that is networking. If I run two containers, why don't they see each other? Why each gets its own IP and why local hosts behave differently? So that's what we are going to solve today using network namespaces. So let's build it from the scratch.
Before we start isolating containers and building networks from scratch, let's first understand what normal looks like on a Linux system. Right now this machine is fully connected to the network, no isolation, no tricks. So let's start by listing all the network interfaces on this machine. For that we can use a IP addr command. So IP space addr. So this command shows all the IP addresses and the interfaces. So let's press enter here. So here you can see two interfaces. The first one is the loopback interface. And here we can see the IP address as well. That is used for the communication within itself. So this interface never leaves the machine. So whenever a process talks to localhost, it uses this particular interface. The second interface is our ENS4, that is our main network. And this is the important one as well, because this is your actual network interface. And this is how your machine talks to the outside world. And inside that we can see the IP address as well. So this is your machine's identity on the network. You will also notice /32 here, which means this is a very tightly scoped IP, usually seen in the cloud environments where routing is handled differently. So now we know who are we on the network. Next question is, how do we reach the outside world? So for that we need to check the routing table. So to check the routing table we can use a IP route command. So IP space route. So this shows the routing table, basically the decision making system for outgoing traffic. So first line is our default route, and this line is the most important one as. So here if you see default via IP address, that means this is for the unknown destination and send traffic to this gateway, that is 10.128.0.1, and it uses the interface that is ENS4. So whenever this machine wants to talk to the internet, so it sends traffic to 10.128.0.1, which act as a gateway. In the next line we can see the gateway itself is directly reachable via ENS4. So putting it all together, we have an IP address, we have an interface, and we have a gateway as well. So right now this system is fully connected, no isolation, no restriction, just a normal Linux host. So now we will create our own network and slowly isolate processes from this host. So first of all, we are going to create a network namespace. So let me clear out the screen first. So for that we can use a command that is IP netns add demo1. So this particular command creates a network namespace. So let me explain this very quickly. So IP netns means network namespace, and add means creates a new one, and demo1 is the name of our namespace. So let's press enter here. So the network namespace got created. So to see the network namespace in this particular system, we can use a IP netns list command. So IP netns and list. So we can see the demo1 listed here. That means the network namespace got created. So now we just created a network namespace, but what does it actually looks inside it? So let's get inside this particular network namespace. So for that we can use command that is IP netns exec demo1 and IP addr. So in this we have used a exec. So that means run a command inside that namespace. And here we are giving a command that is IP addr to see the network configuration of this particular namespace. So let's press enter here. So as you can see, it shows the loopback only, and it is also down. So there is no ETS0 or ENS4, and there is no IP assigned to it. So this is not a limited network. This is a completely new network stack. So as you can see, even the loopback is disabled. So let's fix that. So for that we can use a command IP netns exec demo1, and the command is IP link set loop up. So here we are using the same command that is a exec, and here we are trying to get the loopback IP up. So set loop up means it will bring that particular interface up. So let's press enter here. So it executed successfully. Now let's run the same command again to check the network configuration. So let's press enter here. So as you can see, this particular interface is up, and we can see the IP address also assigned to it. So loopback is as per the namespace, and every namespace has its own local host as well. So at least internally it should be able to talk to itself now. So now let's test the local communication as well. So we can use the same command. So let me remove the IP addr and use ping here, and the loopback IP address that is 127.0.0.1. So let's press enter here. So as we can see, it's working. So right now local communication is working fine. But what about the outside world? So if I try to connect with the outside world, let's run the command that is ping with 8.8.8. So let's press enter here. So as you can see, it's not working. Why? There is no interface, there is no IP, and there is no routes. So this namespace is completely isolated from the outside world. So let's actually prove that by looking at the routing table as well. So if I run the command that is IP netns with exec with IP space route. So as you can see, there is no route and there is no gateway. That means there is no path to the connectivity as well. To really understand this, let's compare it with the host. So let me duplicate the session here. So this is our host machine, and if I run IP space route, so as you can see, on the host we have a gateway, and on the other hand in the namespace we have nothing. And it's not just routing, even the interfaces as well. If on the host, if I run IP link command, we can see the interfaces. But on the other hand, if I run the same command on the network namespace, so IP space link, it only has a loopback interface. So that means interfaces are not shared. So each namespace has its own set of interface. So that means it is truly isolated. Now let's create another namespace and test it. So for that, let me duplicate another session. So let me give a name to this one, that is our network namespace 1. This is our network namespace 2 where we are going to create it, and this is our host. So now let's create another network namespace. So we can use a IP netns add demo2, and if I run the command that is IP netns list, so we can see the another namespace got created, that is demo2. Now if I check the network interface for this one, so IP netns exec demo2 IP addr. So as you can see, it is also having only the loopback interface, and which is also down. So that means this is completely independent. Demo 1 has no idea Demo 2 exists or not. So now let's bring this loopback interface also up. So we can use IP netns exec Demo 2 IP link set loop up. So there is a typo, it should be link. And if I run the same command, so as we can see, the loopback interface is up and it has an IP address as well. So now let's try to check the local communication. So we can use IP netns exec demo2 and ping and the loopback interface IP. So now this one is also able to communicate within itself, but they cannot talk to each other because they don't have any shared network. Now let's actually step inside one of these namespaces. Let's go back to our network namespace 1 and let me clear out the screen, and let's go inside the network interface. So for that we can use IP netns exec demo1 and bash. So if you see, it resembles the same Docker command which we use generally, that is docker exec and the container name and the bash. It also follows the same structure here. So let's press enter here. So now we are inside our network namespace, and if I run IP addr here, as we can see, it only has a loopback interface. And if I check the IP space route, so there is no routing table. So this feels like a completely separate machine. So let's exit from this. So now let's connect all the dots. A network namespace isolate interfaces, routing table, ARP tables, firewall rules and sockets. So this is not a partial isolation, this is a full network stack isolation. And this is where containers comes into the picture. So far we have been creating namespaces manually, but containers don't do it in this way. So they don't create namespace separately, they create them on the fly for a process. And that's exactly what we are going to do now. So we are going to use an unshare command. So let me clear out the screen first, and I'm going to use a command that is unshare -net and bash. So unshare means create a new namespace, and -net means creates a network namespace specifically for this process. So now let's press enter. So now we are inside the new network world, and if I run IP addr, it's having a same result, right? Only the loopback and nothing else, and which is also down. So this should look familiar. It's exactly what we saw with the demo 1. But here's the difference. We didn't create a namespace first, we entered it directly with the process. And this is exactly how containers work. They don't feel like VMs because they are just processes running inside their own namespaces. That means container is equal to processes plus namespaces. So let's come out of it. So for that we can use an exit command only. And if I run the IP addr now, so as we can see, it has a two interfaces because we came back to the host interfaces. So now we have seen both the sides, manual namespaces and process level namespaces. So now let's clean everything up. So for that we can use a command that is ip netns delete demo1. So we have deleted the first namespace, that is demo1, and if I list it, so ip netns list. So as we can see, demo1 got deleted. So similarly, I'm going to delete another namespace, that is demo2. So now we have deleted both the network namespaces. So as you can see, everything is gone. So now a network namespace is not just isolation. It is a completely independent networking stack with its own interfaces, its own routing, and its own rules. And that is the foundation of container networking.
Right now, these namespaces are completely isolated. They can't talk to the host. They can't talk to each other. So how do containers actually communicate? That's exactly we are going to build up in the next video. If you found this video helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.